Okay, chapter 10, I put the most important concept here for the extra credit. And all you have to do is just take a note. You don't need to answer question like a test. You answer question by taking a note. In other words, I'm going to tell you all the answers for this extra credit. Not like the previous chapters, I have video for each sections. And start from chapter 10, I may not have video for each sections, but all the concept for each section, I write down all the information on the classwork PDF file. So it's the same as the video information, but there's no audio. Not you won't have video to hear my voice, but all the important information still there on the classwork PDF file. Now this chapter 10 extra credit is the overall very important concept for square root. And without this concept, you won't understand anything I talk about on each section PDF file. Okay, so this is very important. Now, when you have the question talking about find all the square root of A. So let me choose the color. Find all the square root. So chapter 10, mostly we are talking about the square root. But when you want to find the square root, you are going to see three different type of the question. One is they ask a question by in word. Okay. And the other type is they use equation. Solve for equation. And then the third type is they use a symbol. Now, you have to pay attention for how many solutions. If I ask you in word, so write down in the sentence, find all the square roots of A. You need to have two solutions. So for X, when you have equation, you still need to find two solutions. But when I give you a symbol, you need to give me only one solution. If you give me two answers, I consider you didn't learn the concept well. So you won't even get the partial credit because the concept here is one answer or two answers. And if you give me two answers, I won't consider you work very hard. I only need one answer and you give me two answers, you are so good. No, it means you didn't understand the definition of the square root function. So when I use a symbol to talk about square root, it's only one answer. So right now, very important is why there are two answers or one answer. So let's use some example here first. And then I will go back to talk about the concept. So if I have equation, or say in word, find the square root of 1. Now you understand positive 1 square is 1, negative 1 square also 1. So when you have equation or say in word, by the concept, these two need to have two solutions, positive, negative, right? Okay, but because you don't know what's A, so you don't know what's the answer. But From the example, we can guess. This is positive, negative 1. Yes. And we are going to skip these two for now. And then whenever we are able to guess the answer, then we guess positive, negative 2. Because 2 square is 4. Negative 2 square also 4. You can guess. 5, 6, 7. If you use calculator, they may give you some decimal answer, and the computer will only give you one answer. And how come we need to have positive, negative? So by the concept, obviously, I'm able to find two answers. Then you need to give me two answers. So calculator, why the calculator only give you one answer? I will explain later. Okay? And here, x squared equal to 9. 3 squared equal to 9. Negative 3 squared also equals to 9. So when I say find the square root for 9, or I use the equation, ask you to solve the equation, obviously you need to give me two answers, one positive, one negative. Okay, so I would like to go back here. Yes, by the concept, you need to give me positive, negative 2. But the positive, negative 2 what? For example, if you have x squared equal to 2, if you use calculator, it will be 1.414 something, something, something. Basically, it's not repeating all the 141414 forever. It's something different, no pattern at all. We call this irrational. Irrational number. This irrational number, no pattern. No pattern for digit. And if I ask you to give me answer, if you say positive, negative 1.14, whatever you wrong, it's not accurate, not 100% accurate. I won't say it's wrong, but it's approximate. Approximate solution. Without talking about approximate solution, actually you need to give me accurate solution. But what's the accurate solution? Without calculator, even with calculator, it's hard. So in this case, the mathematician create a new symbol. We use this symbol. Okay, we call this symbol square root, also square root. But this symbol is not positive, negative. Okay, so say if we have two answers, we need to have positive answer and a negative answer. And this square root means positive or negative. Okay, so that's a concept you want to talk about. I want to talk about. So let me erase all the handwriting here to make sure it's readable right now for you. So that's irrational number. You can take a note for now, but for the accurate answer, how can you use a symbol to represent an accurate square root of 2? So the mathematician, they create this symbol. Okay, so the answer of the square root of 2, you say square root of 2. But you still need a positive, negative, because we design the square root as a function. Now remember, recall the concept of from chapter 7. If we have a function of x equals to square root of x, if you input 1x, we say 2. If I input 2, right? If I input 2, then output need to have only one answer. If you say this is 2 answers, wow, it's not a function. One input only have exactly one output. So, positive or negative, the mathematician choose for you. This square root represent the positive solution. Then what happened to the negative solution? So if you say x need to be square root of 2, the solution need to be square root of 2, then there's only positive one. So you still need to create a negative solution. Here I think it's better I use A. Because right now this is A. This is A, right? So you input A is 2 and the output square root of 2. So if we have A is 2, oh, I want to change color. So when A is 2, the answer is square root of 2. So for the function, if f of A is a function, then it means this function is only one positive answer, no negative. But if you want to solve for the equation, then you need to put the positive negative. So when I ask you to simplify the square root of A by the symbol, if I use a symbol, then only one answer, because this symbol represents the positive solution only. Okay, so I can go back to this one, square root of 1, and you need to add positive negative by yourself. Oh, why? Don't change color. So you need to put the positive negative by yourself. Okay, so keep going. Here you need to have positive negative. Keep going. Okay, we need to have two solutions: positive negative, positive negative, positive negative. And then if we are not able to guess exactly what's the answer, like 1 you can guess, 2 you can guess, and here you have no way to guess the answer, so mathematician created this symbol, and basically I call this cheating. Because what's this? You have no idea, right? But this symbol, even though they don't tell you exactly square root of 2, the solution for x squared equals to 2 is square root of 2. Everyone knows that. But when you say square root of 2, still you don't see what's the solution, right? So that's why I call it a cheating. This symbol is kind of cheating, but very important symbol is you can use this number to represent the solution, and its big difference. Compared with square root of 2 and the square root of 3, it's a big difference. So this is square root of 4, right? Square root of 4 and the positive negative. So you can tell square root of 2 is different from square root of 3. Square root of 4 is greater than square root of 3. It's obvious. So even though it's cheating, but it's still useful. Very useful symbol. Okay. So we can use this notation. So for x squared equals to 5, the x will be square root of 5. So right now I want to tell you something very important concept is when you get rid of the square, you need to you change the square to become positive negative square root. Make sense? This square become positive negative square root. Square is positive negative square root. Okay? When you get rid of square, it's not just the square root. You need to have positive negative and the square root. So you inside square root, you just put the 6, 7, 8. Okay? And then here square and become positive negative square root. Square, positive negative square. Square become positive negative square root. So you have 10, 11, 12. Okay? But remember, this means positive. Okay. So square root of a, what it means? Means this number after square need to be what? A? Yes? Right. Square root of 2 after square is 2. Because the square root of 2 is the solution for x squared equals to 2. So if you square x, when you square x, then you have a. When you square x, you have 3. So when you square x, then you have 3. You cancel out. So if you square root, you can simply cancel out. So you can square. Okay? So this is one of the very important knowledge you have to understand here. Now, so I think I explain why sometimes you have two solutions, sometimes you have one solution. One solution is only when you use a symbol. This symbol, because this symbol means a function, so need to have only one answer. Otherwise, you're supposed to have two solutions. Okay? And if you have more questions, you may ask me in the class, or you email me, and I will create a blackboard for you, to whiteboard for you to explain more detail. Okay, so let me erase those marks to make everything easier to read. Okay. Okay. Oh, I think that's pretty easy answer. So you can so when you go back to read, it's easier to read. Okay. Now keep going, we talk about the cube. Unlike the square, you have positive negative square root, right? X cubed is always one answer. Why? If 1 cube is 1, negative 1 cube is negative 1. So when you have odd degree, odd exponent, you have only one answer. And when you have even degree, even exponent, you need to solve positive negative. If you have second degree equation, you need to find 2 solutions. If you have 3 degree, you're supposed to find 3 solutions. How come here we only try to find one answer? Basically, the other 2 solutions are the irrational solution. So we don't talk about detail here so far. We can solve it later, okay? But we are talking about the real solutions. Okay. Real solutions. And here x cubed equals to 1, we have 1. Now, the rest you cannot guess. And here, wow, x cubed equals to 8. We have 8, 2. 2 times 2 times 2 is 8. If you try to use negative 2 times negative 2 times negative 2, you have negative, negative, positive. Positive, negative is negative 8. So negative 2 is not a solution, obvious. So when you have cube equation, you can only find one solution. Okay, this is 3, this is 5. How about if I change the question to negative 1, then you have negative 1. Okay, if I change the question to negative 8, then you have negative 2. If I change the question to negative 27, then you have negative 3. Negative 125, you have negative 5. Okay. So here, so when you have cube, you have other degree. Basically, no confusion, only one answer. The most confusing part is when you have even degree. And pretty soon we are going to talk about more confusing concept is when you have even degree and equal to negative. Wow, then it's hard, right? So basically, this chapter 10, the hardest part is when there's an even degree and equal to negative. Then obviously it's not a real solution because for any real number after square need to be positive. How come it is equal to negative? That's the next thing we have to talk about. Okay. So keep going. So I will say when x cubed equals 2, if you have no way to guess the solution, so the mathematician create a symbol for you. Okay, cube root. That's cube. Cube means you have height, length, and width. 3 dimensions. Cube. So you have cube root. So you have 2, 3, 4, 5. Okay. So when we talk about x cubed, oh, I want to change the color. When I talk about x cubed, then answer need to be 2 because x cubed equal to 2. So means this cube cancel out, right? This cube, if I try to cube, cancel out is 3. If I make a cube, I cancel out is 4. Cube, I can cancel out because x cubed need to be 5. So this new symbol, same as the square root, you can cancel out with the outside cube or outside square. You can cancel out. So here, that's the same thing. We keep going. Now, same thing. If I try to talk about Let me see. Okay. So basically, you can say this cube root of negative 27. And the cube root of negative 27, x is negative 3. And if I try to make a square, square, same thing, cancel out, answer is negative 27. Okay. So the next thing here, if I go back to x squared equal to negative 12, what happened? Then this becomes negative 12. And if I try to square, positive after square is positive. And if I cancel out, answer is negative 12. Okay, by the definition, this is the most confusing part. Next, we want to learn from chapter 10, especially 10.1, homework. Okay, so why this happen? Because x squared need to be negative 12. If I change the questions to say, if x squared equals to negative 12, then x squared need to be negative 12, right? So, means square root of negative 12 after whole thing square need to be negative 12. In other words, you may cancel out outside square with square root. So if I have negative 11, then this negative 11. If I try to make a square, then I can cancel out square with square root and still negative 11. Positive is positive. Okay. So this is one of the very hard concept, and actually it's very easy to explain but hard to understand. Easy to explain is because x squared is negative 11, right? So just by the definition of the square root. Now there's one thing. Then we can keep going. We try to do some easy even root action. So when you want to solve for square, you cancel out square and put a positive square root. I talked about that already. You cancel out the square, put a positive square root. Cancel out fourth, put a negative square, fourth. Okay, put this positive fourth degree. Now when I don't write down 2, it means 2, okay? Other than 2, you need to write down what's the index number. This is the degree, right? But here is index number. Okay, so you put a 64, A, 64, A here. Now, for the odd, when you get rid of the cube, when you want to solve for the cube, don't put the positive 64. Okay, just the cube. So it is cube A. 5, 5th degree, 64. Right? Okay, so for the other root, there's no positive. For the even root, you need to put a positive. And when you have 4th degree, you're supposed to find more answers, actually. Okay, but right now we just talk about the concept. For 4th degree, you're supposed to find more answers, not just 2 answers. So this just extra information, but you don't want to pay too much information here. Okay, now remember earlier I talked about when you put the square for the square root outside the square root, you may simply cancel out. So which one is the outside? Part B, you can simply cancel out outside and the answer is A. But what happens if n is inside? Then you cannot cancel out. You cannot. Okay. So depends on A is positive or negative. Actually, remember the square root of A, you have only one solution, not a positive, negative, only one solution. So if A is positive, then they are equal. Okay, when A is positive, square root of, sorry, when A is positive, then they are equal. They are equal. This is also A. They are equal. The only trouble is when A is negative. When A is negative, and if that's odd degree, still no problem. The only trouble is when A is negative and the index number is even number, then that's a real trouble. They won't be equal. So let me explain and let me use some example to show you. Okay. So if you want to say cube root of 27, cube root of, let me use 3, smaller number, easier. Cube root of 3, cube root of 3, and the cube outside. Let me change color for here. Okay. If this cube inside or cube outside, they are all positive. So no problem, they are equal. So this is 3. This also 3. Why I use all the 3? Sorry. It's not a good example. Let me change it to, how about, let me change it to 7. How about 7? Okay. So this is 7, this is also 7. Now, if I change it to negative, then answer will be negative. They are the same thing. Let me rewrite. Okay. Let me use 27. I think it's better. Use 27. You can simplify to understand better. So let me use 27. Answer is 27. Back. Sorry. Okay. 3. So this is 27 is 3, right? This is cube root of 3 times cube root of 3 times cube root of 3. So it's also is cube root of 27 is 3. So because it's all positive, it's the same thing. Now if I change it to negative, okay. Now if the cube is outside, or inside, you can see that because other number for the negative is still negative, and this is by the definition. Okay, I don't suppose to show the work because by the definition always cancel out. Okay. And this negative 3. So if you have cube inside the root, Negative still negative. And by the definition, negative still negative. So they are equal. So no matter this A is positive or negative, when the index number is odd number, they are always equal. Someone erase. Okay, so here, so when the index number n, this is n, is odd, so no matter A is positive or negative, doesn't matter. This is A, this is A, this is A, this is A. Okay, when the degree is outside, you may simply cancel out. That's by definition. Okay, and this, because the other degree, we just show you the example. Okay, you can cancel out. Still A, no problem. The problem is when you have even degree, when n is even. Okay, when n is even and the A is negative, that's the problem. And go by definition, outside, inside, outside, inside, always cancel out, and the answer will be negative. Okay. Now, but if the square is inside, follow order of operation. Order operations. Remember, when you have square inside the root, you need to take care of square first. So after you take care of the square, a square become positive. Okay, a square is a positive number. This positive number, so square root of positive need to be what? Positive, not negative. So will be equal. Okay, so the key point, the most important information here for 10.1 homework is when you have square or when you have even root inside the root, this 4 is inside the root. You cannot simply cancel out. You cannot do that because this even degree already guarantee inside whole thing become positive. And the fourth degree of and the fourth degree of positive need to be positive, not negative. So how you, but say if you don't know what's A, then you still need to put then you have to put absolute value. Okay, you need to put the absolute value. So let me erase all the work here and then let me show you what you do. Okay, so when let me talk about when A is positive first and then go back to negative. Let me give you an example. So if you have a square root of 3, square is 3. Square root of 3 outside square is also 3. There's no doubt because they are all positive. So these two are equal. So most of the time, A equals to B. This n is inside or n is outside. Doesn't matter. When A is positive, it's all equal. Okay? But when the problem is when A is negative, then that's the problem. When A is negative, this is negative, this is negative. Wow, no. When A is negative, well, depends on even or odd. Okay, so I cannot just put the absolute value because there's a two possible answer. If A positive or if A negative, positive 0. Okay, if 0, everything is 0, you don't need to worry about positive or negative. But if A is positive, then no problem. It equals to, so this one equals to A. But if A is negative, then this one equals to A absolute value. Because you need to guarantee is when n is even. Okay, when n is odd number, doesn't matter. Negative is negative, positive is positive. Okay, so again, let me erase this. So I won't make the formula say A equals to B. I won't say that. Depends on the index number. If index number is odd number, then they are always equal. Okay? So if n is odd, then A equals to B always. But if n is even and A is negative, okay? So if n is even and A positive or equal to 0, then also A equals to B. So I will say most of the time, even or odd index number, A mostly equal to B, except when n is even but A is negative. Okay, that's the only problem. So I want to talk one more time. So mostly when there's no problem, A equals to B. So situation 2, n is odd, then A equals to B. No problem. Okay? It's always equal. No problem. And when n is even, the only trouble is when A is negative. So that's the only situation we want to talk about. And that's the homework. You have to, sometimes you need to put the absolute value. Sometimes you don't need to put the absolute value. And I'm telling you why right now. So one more time, let's review all the concept here. When A is positive, don't worry, there's always A equals to B. Part A equals to part B. Okay? But when inside the root is negative and for the even root, then because of the square guarantee everything is positive, when even root inside the root means this. So your answer need to have absolute value. Make sense? So yes, you can kind of cancel out, but you need to guarantee it's positive. And this is part B, right? This is part A. So when n is even, and this inside A is negative, then you need to guarantee absolute value. But if square is outside the root, then just by definition, it's just equal to A, and it's negative. Okay, and A is negative. So when A is negative, then we say negative A, because negative become what? Positive. Make sense? If A is negative, how you get rid of absolute value? Negative A. So negative, positive. So this is a very important concept here, and when you, after you watch the video, probably you are going to have more questions. Then you may ask me again, that's fine, or you already understand, but you need to try first. Okay, now the last part before I end this video is show you how to show the work when you want to simplify. So for example, if you have square root of 8, you say this is pretty easy, simple answer. You say this can this one be the answer to submit for your test? I will say not yet. Okay, not yet. Not simple enough. So how you simplify the answer? So 8 equal 2 cube. You need to factor to the prime. Prime number means 2, 3, 5, such a number. Okay, so 2 cube, you want to separate. Do you have complete degree? So like in this case, you have complete square, 2 square times 2. So 2 cube is 2 square times 2. You separate them. Square, no square. No square. Now, when you have square, you may cancel out. So you have 2 here. And copy the second part, right? Because you cannot simplify anymore, but you can simplify the perfect square. So let's try one more time for 16. 16 is 2 times 2 times 2 times 2 is 2 to the 4th degree. But right now, you have cube root. So it's 2 cube times 1. So you have 2 cube times 1. And the perfect cube cancel out. So this part, first part is 2. And copy down the second part. Then you are done. Okay, so that's the formula for you how to show the work. On the test, you do need to show work. And that's how you show work. You need to show me how you separate perfect 4th degree, no 4th degree. Perfect cube degree, no perfect cube degree. So this x5 is 4th degree times 1 degree. 6 is 4 plus 2. You have y cube, right? Y to the 4th. And this is 4 plus 7, 3, right? 7 is 4 plus 3. So you have G4 and G3. And then you cancel out this part. So that's your answer. But remember, because you don't know x, y, z are positive negative, so you need to put the, after you cancel out, you need to put the absolute value. So that's the hard part. So after you cancel out, when you cancel out the even degree and you don't know x, y, z are positive or negative, then you better put the absolute value. And these are real number. 2 is already positive, obviously. You don't need to put the absolute value. And this, how many thousand? 10,000. 10,000. I factor for you. You can, how you factor? You can use upside down. upside down division. Upside down division will guarantee you have enough space keep going down, not like a division you keep going up. Okay? So first you divide by 2 and keep going, you can keep going. I have no space, so I keep going to divide by 5 here. So basically this is 2/4 times 5. 1, 2, 3, 4, 5. 5/4 degree. So 10,000 is 2/4 times 5/4. So 4 degree, you have 2 cubed times 2. And this is 5 cubed times 5. So you have 2 cubed times 2. And 5 cubed times 5. And you have already perfect cube. So in the end, you have 10. And the cube root of 10. That's how you simplify. Okay. So I'm done with this video with very important concept. Now, other than those concepts, we have some minor concept not included here, but I already written on it's already been written on my PDF file for you. So you can take a look when you are doing the homework. Before you try 10.1, you need to watch this video, and then you try 10.1 homework. Each session, you need to refer to my PDF file. Each PDF file will show you how to do the homework, help you with the homework and with the concept, and tell you how to show work. Okay, so on my test, show work is very important. If you don't show work, you earn 0 credit. Okay, so see you next time. Bye bye.